Hello, my name is Mark Smith. I'm going to be talking about the Open Headset Interconnect Standard today. Who am I? Again, my name is Mark Smith. I sometimes go by Smitty. My call sign is N6MTS. I am the president and CEO. I don't like how that sounds. Let's go with head cheese. I am the head cheese of Halibut Electronics. I'm a host of the Ham Radio Workbench podcast, and on YouTube you can find me as @SmittyHalibut, and on Mastodon or the Fediverse you can find me as @Smitty@halibut.com. I've been a ham, an active ham, since 1992-ish. I got my call sign in high school. I spent 2 years as an electrical engineering student at Cal Poly San Luis Obispo, but ended up getting my degree from Cal Poly in computer engineering. The last 30-ish years, including time in college, I have been working in IT with network engineering and systems administration and information security. But I left IT back in 2021 and started Halibut Electronics to make ham radio and audiophile electronics. So let's talk about Open Headset Interconnect Standard, OHIS. What does that mean? Well, open. Open refers to the fact that this is an open standard, meaning any individual or company can make devices that are compliant with this standard with no obligations, no licensing fees, no nothing. It is an open standard, free as in speech. Anyone can use it. Headset. It describes the signaling commonly found between a user and a radio, things like the microphone, the headphones or speaker, and the push-to-talk. Interface, as in it describes both the physical and electrical connection of those signals between the user and the radio. And standard, meaning that devices built to this standard will work with other devices built to the same standard. All right, so what are we talking about with standards? Well, in ham radio, we have various different standards. For example, for RF, 50 ohm coax is kind of a standard, an electrical standard that we've all centered on, and pretty much all radios will either use 50 ohm coax or 450 ohm twin lead. For example, for a similar example, in power, we've mostly standardized on 13.8 volts DC, plus or minus 15%, right? And with those electrical standards, I can take a power supply meant for one radio and use it on another radio, or I can take an antenna from one radio and use it on another radio. Now, there are various different physical standards for these electrical standards, but because there are relatively few of them and because the electrical standard is the same, it's pretty easy to convert back and forth between the physical standards. For example, with RF, we've got, PL259 or Type N or BNC, but we can also make adapters that go back and forth between those. Similarly with power. On the left there, you see kind of the 6-pin Molex, but not really Molex connector that's common on the back of HF radios. Or on the right, you've got the T-shaped blade pin connector that's common on mobile rigs. But in both cases, they work with Anderson power poles, which is a kind of an adopted standard. And it's easy to convert back and forth between those. We have no such standards between the user and the radio. There's no electrical standard there. For example, the microphones. Microphones are all different. Does a given radio use a dynamic microphone, an electret microphone, or a carbon equivalent? Is it balanced or is it single-ended? The audio out from the radio, is it line level, is it headphone level, or is it speaker level? Is it ground referenced or is it push-pull? Is it mono or stereo? The PTT, this is a little bit easier. Is it like a GPIO style contact closure to ground? Or, as is common on HTs, is it do you complete the microphone circuit? Do you put a switch in series with the microphone and allow it to pass DC? That's a common way for HTs to trigger PTT, right? There's no standard between the radios for those. There's no electrical standards. There are a lot of electrical standards, and you can't necessarily take a device meant for one radio and use it on another. There are so many to choose from. Even the physical standards are different. Microphone, is it a 3.5 millimeter TRS? Is it a 1/4 inch? Is it an XLR? Is it that 8-pin round aviation connector? Spoiler, those are called GX16s. Or is it an 8-pin modular, like an RJ45? Some radios use 6-pin modulars. And even when you have the same physical connector, it's very common for them to have different pinouts. What about the audio out from the radio? Is it 3.5 millimeter, or is it quarter-inch TRS? Or is it RCA? On the PTT, is it on the mic connector? If you've got one of those 8-pin, multi-connector microphone lines, the PTT is often in there. But some radios, it's separate. And if it's separate, is it a quarter-inch TS, tip and sleeve, or is it 3.5 millimeter, or is it RCA? Right? There are just so many different physical connections to that different radios use. So let's look a little bit closer at the problem here. I've got a Heil Pro 7 headset. Great headset. Dynamic microphone. Bob Heilman knows how to make great microphones and headsets and everything else. It has a 3.5 millimeter TS tip and sleeve 2-pin connector for the microphone, and an 3.5 millimeter TRS stereo plug for headphones. But the microphone connection on my Yaesu FT920 is that 8-pin round socket on the front of the radio. All right, good news. Bob makes an adapter for us, so we can buy an adapter for that. But I've got a Kenwood as well. And the Kenwood has the same physical connector on the front of the radio, the same 8-pin round connection, the GX16. But if you look closely, the pinouts are different between the Kenwood and the Yaesu. All right, so what do I do here? I want to connect that same headset to my Kenwood radio as well. Well, good news, Bob's got another adapter for that. Thank you, Bob. What about ICOM? Right, let's go down the list. I've got that same Heil Pro 7 and the ICOM 7300. It's the same physical connector, right? So surely it will work with at least one of the adapters I already have. No, all three manufacturers have different pinouts. So Bob still has me covered. He makes a third adapter for the pairing between his headset and the radio. But there's another problem here, is that ICOM uses an electret microphone, but all of the other two, the Kenwoods and the Yaesus, use a dynamic microphone. And Bob's headsets typically come with dynamic mic elements, unless you explicitly buy the IC element, which is an electret microphone meant for the ICOM radios. And so now, if I want to take this headset from my Yaesu to my Kenwood to my ICOM, I need to swap out the mic element, because the ICOM won't work with a dynamic radio, but the Kenwood and the Yaesu won't work with the electret mic element. So to use the same headset on all of these radios, I have to swap out that mic element. Well, that's kind of a bummer. Well, what if I got a different headset as well? A very common standard headset these days is the PC gaming headset. The standard for the pinout is actually called CTIA. It's a telecommunications, cellular telecommunications standard. And it's a 4-pin, 3.5 millimeter connector, left and right and ground and microphone. So you can fit both your headphones and your microphone on a single connection. But again, that doesn't fit into my Yaesu FT920. All right, I can make an adapter for it, but now I've got 3 more adapters because it's a new headset. And so I've now got a total of 6 adapters for everything. Oh, and by the way, that CTIA microphone is an electret microphone. And if I tried to use it on my Kenwood or my Yaesu, first off, I'd have to give it bias power. Secondly, its output is way too hot. So now I have active electronics. Well, okay, nothing active here. These are just capacitors and resistors, but I do have a power supply in there. I have electronics that I need to insert into the microphone between the microphone and the radio for that microphone to be able to work. Right? So I got some active electronics there. It's not just a simple adapter. I got more bad news. That 4-pin 3.5 millimeter TRRS socket, there are, of course, 2 different standards for it. I've got the CTIA standard where ground is on ring 2 and microphone is on the sleeve, or the OMTP standard where microphone is on ring 2 and ground is on the sleeve. Point being, your adapter game is very strong. This is quickly getting out of hand. To work with all headsets going to all radios, to make that an option, you need to have a full mesh of adapters so that for any given headset, you have an adapter that works with any given radio. And for all your headsets, you need to have an adapter for all the radios. And that's a full mesh, and that's a lot of adapters, and it kind of gets annoying. So how do we address this? Enter OHIS, the Open Headset Interconnect Standard. So here is a quick overview of how OHIS fits into your station. On the left-hand side, we have these user devices, or examples of user devices. Ideally, in a perfect world, the equipment manufacturers will adopt OHIS natively. So at the top, I have a OHIS compliant headset. That is a headset that just has an OHIS port cable sticking out of one side. Right now, there aren't any of those that exist, so we have to use adapters. And we call them here on the user side the user adapter. So you plug in a normal headset and a PTT, and it does all of the configuration changes, all the electrical changes to convert whatever that headset is into the electrical standard that is OHIS. And on the right-hand side, again, ideally, the radio manufacturers would put an OHIS port on the front of their radios natively, and you could just plug any OHIS compliant headset into the front of the radio. But until we have that adoption, we're going to be talking about adapters. And so we talk about this radio side adapter, which has an OHIS port on one side, and then all of the electronics that are unique to that radio, and adapts whatever that radio has to the OHIS standard. And then OHIS is the part in the middle, right? It is the standard in the middle. The radio adapters have an OHIS port on it, and the user adapters have an OHIS port on them. And those ports can connect directly to each other, regardless of what radio is behind it. All the complexity that adapts the standard interface into whatever that radio needs is handled in that one adapter. And that adapter stays with that radio and never leaves it. And then similarly on the headset side, you have an adapter for that one headset that converts that one headset to the standard. And that adapter stays with the headset and never leaves it. And now both my headset and my radio have these standard interfaces that can connect to them. And these dotted lines in the middle here are not saying that all headsets are connected to all radios at any given time. It's still a one-to-one, but they're just showing which connections are possible, right? This headset can now connect to any of these different radios without having to worry about what the complexities of whether you've got an adapter that is unique to that pairing of devices. So that's the goal. Let's do a quick rundown of what the electrical standard is for OHIS. The microphone is electret level, which is minus 45 dBV, give or take. It is pseudo-balanced, which means it has its own ground return line. It's not a shared ground. And plus 5 volt DC bias voltage is provided by the radio back toward the user device. The audio out from the radio toward the user side is headphone level. It's about 0 dBV full volume. It's most of the time a lot less than that. It is ground referenced, and it has its own dedicated ground. It is not push-pull like a speaker output often is, and it is capable of carrying stereo audio. PTC is a simple contact closure to power ground. And I say power ground because power is optionally is also provided as the standard in the standard. So 5 volts DC up to about 200 milliamps is provided by the radio toward the user device for anything that the user device may want power for. It's optional, and there will be some user devices that require power that won't work with a radio device that does not provide power. But a lot of user-side devices won't require power, and so they'll work on radio-side devices that don't provide power. The physical summary, the physical standard is the connector on it is an 8P8C modular, often referred to as an RJ45. Technically, that's incorrect, but we'll go with it. So it's an RJ45 or 8P8C. The cable itself is shielded Cat5 network cable or better, Cat6, Cat7, whatever. Honestly, even Cat5 is overkill from a category standard, but you don't really see shielded Cat3 cables. The shielding is the important part here. The RJ45s are wired up as TIA 568A or 568B. If this doesn't mean anything to you, don't worry about it. The important part is that there are certain pins that need to be pairs. Microphone is on two particular pins that need to be a pair for noise rejection. What all of this means is that you can use common off-the-shelf Ethernet cables. You don't have to buy a custom cable or some unique expensive cable. Just off-the-shelf shielded Ethernet cables will work for OHIS. The pinout is shown here on the screen. You don't have to write this down. There will be a QR code at the end that links to the website, which you can see in the upper right-hand corner, ohis.org, that has all of these details. But really quickly, these are the different signals. There are 3 pins for headphone. You got a headphone left, headphone right, and headphone ground. Then you have 2 for the microphone and microphone ground. Notice separate from the headphones. And then you have VCC and power ground. Again, separate from the other 2 grounds, and then a PTT signal that is just a contact closure to ground. Excuse me. In this particular example, we are showing an electret microphone, and if your headset uses an electret microphone, then you don't need to do any electrical connections or any active electronics between the OHIS interface and your microphone. It'll just work straight as it is. But if your headset has a dynamic microphone, you will need to have a small preamp here that converts the dynamic microphone up to an electret level. And that is a common enough thing that's going to need to happen because dynamic microphones are very common. Like I said, all of the Heil microphones that the common Heil microphones are all dynamic. So as included as part of the standard, available for anyone to use, you're not forced to use it, but it's available for anyone to use, is this very simple microphone preamp. 3 resistors, a capacitor, and a transistor. It runs off of the bias power that the OHIS radio side is obligated to provide to the user side. So you don't even need to use the VCC signal off of the OHIS. It's just using the bias power from the microphone line. This bias power is required for electret microphones. So this mic preamp uses that same power. And you plug in a dynamic microphone element into this preamp, and then the output of this preamp looks and behaves just like an electret microphone. So this is included in the standard as a way for turning common dynamic microphones into an OHIS standard electret level signal. All right, so when is OHIS useful? It's most useful when you're in a multi-user environment. Whenever you've got several different radios and several different headsets that you might want to move from one radio to another, right? So when you're in a multi-user environment, like an EOC or a field day event or a club shack, I bring my headset to this event, and I want to use my headset, and I don't want to use your headset because your headset has your ear goobers in it. My headset has my ear goobers in it. I don't want you using my headset. So I would very much like to be able to just plug my headset into whatever radio I happen to sit down at. Same thing with an EOC. If I get called out for an emergency event, I want to be able to use my own headset there. I don't want to use a headset that's got somebody else's dandruff or whatever in it. It's just from a cleanliness perspective, I want to use my headset and keep it to myself. So these multi-user environments is where this really shines. It also becomes handy as a way of presenting a common electrical interface between the radio and the user if you want to make a device that goes between the radio and the user. You don't see a lot of devices that go between the radio and user right now because that device would have to be designed to handle all the complexity of the different options when talking to the radio, and similarly when talking to the microphone. What are the physical connectors? What kind? All the electrical signals, all the stuff that we talked about at the beginning of this presentation. Any device that you make that goes between the radio and the user now has to deal with all of that variety to be able to be sold into, to work with any radio that it wants to. As soon as we have a common standard like OHIS on all of our devices, now I can design that box in the middle, that device in the middle, to that one known, well-defined electrical standard. And that makes designing those devices so much easier. Spoiler, that's one of my motivations for doing this, is that I want to make those devices that go between the user and the radio. But I think OHIS is useful more generally anyway. All right, when is OHIS overkill? If you've only got one radio or one headset, or any situation where the full mesh problem doesn't apply, right? Like in your home shack, it may or may not make sense to deploy an OHIS compliant environment or to add money or spend money on the adapters when you've only got one headset. At that point, it's probably easier just to buy the specific adapter for the pairing between your headset and all your different radios. That'll be a simpler solution. Or if you've already got all the adapters you need, at that point, then you definitely don't need to buy yet another adapter for OHIS. Or if you've got a good reason to prefer the simplicity of only a single adapter between your headset and your radio, right? With OHIS, you've got two adapters, one on the headset side and one on the radio side. And that adds a little bit of complexity. So if you've got a reason to be adverse to that complexity, then having a single adapter there makes sense. So why am I proposing this as an open standard? Well, because open is how we get out of this mess. 50 ohm coax and 13.8 volts. We got 13.8 volts from cars, right? Because that was the voltage that alternators ran at and our 12-volt electrical systems in the cars operate at. And so we hams sort of inherited that as our standard DC voltage for powering our radios. 50 ohm coax, I think we mostly inherited from the military, if I remember correctly. I don't know the exact history on that, but we have kind of settled down on those standards. But we don't have anything like that and for this. And if I were to try and make a proprietary standard, I would have such a hard time of getting buy-in from the equipment manufacturers. I think that is my single biggest goal, is to try and get buy-in from the industry and have people realize that, yeah, this is something that would benefit the community if we had. And the only way I'm going to be able to get that sort of buy-in is by going open. And so that's what I've done. The other thing is that it makes a good DIY project, right? These adapters are not that hard. They're not that complex. And I don't want to try and claim any sort of intellectual property or design rights or licensing fees or anything like that, right? I want people to be very open and free with their designs. I want open source designs. Yes, my company, Halibut Electronics, sells adapters for these, but that's not my primary goal. My primary goal is adoption and not proprietariness. And, DIY projects, the getting people to build things in amateur radio is a noble goal, in my opinion. And I think this makes a really good good case or a good kit for that, or a good project, because it's low voltage. There's no RF. It's very forgiving. Audio is very forgiving compared to RF. And so this would be a really good project for people to work on their own. All right. If you want to learn more about OHIS, or the Open Headset Interconnect Standard, go to ohis.org, or you can scan the QR code on your screen right there, and learn more there. On that page, ohis.org, is a link to the full standards document. It also links to our GitHub repo, where that standards document and a bunch of the diagrams and everything else are, and our groups.io list. There's a link there to our groups.io list. If you're interested in participating in Open Headset Interconnect Standard, if you're an equipment manufacturer or a company that builds and creates kits and sells kits for amateur radios, or if you're just an individual and you would like to try your hand at building an adapter on your own, or making a product that is OHIS compliant, please visit ohis.org, sign up for the groups.io mailing list, and start your conversation there, right? Ask your questions. I'm on there, obviously. I moderate it. But there are several other people there who are also interested in Open Headset Interconnect Standard, and we would love to make this a reality. So until then, I will see you on the mailing list. Thank you very much, and be good humans.